So I'm waiting for you guys before we commence our live stream. Our topic for today is periodic table and periodicity. If you are here, just let me know so that we can start the class. If you are here, you can use the chat box. Just use the chat box. Okay, Farida Usman is here. Okay, you people are here already. Well done, well done. So I would love you guys to be liking. Just be tapping on your screen, just like we do on TikTok as well. Okay, so our topic for today is periodic table and periodicity. That's what we'll be doing for today. And you people know that periodic table and periodicity is something that JAMB sets a lot of questions on. Something that JAMB sets a lot of questions on. Okay, so now this is what we'll be solving for today. I'll be explaining to you guys everything you need to know on the periodic table and periodicity, right? So at first, I want to ask you people, I want to hear from you people. What is periodic table? To you, tell me what periodic table is, because questions can come in any form. What is periodic table? Everybody, I want to hear from you people, because on this YouTube live, this session is being recorded so that people can watch. So you people should participate, you understand? So what is periodic table? In your own words, how can you define periodic table? In your own words, how can you define periodic table? Okay, Moyo, sorry, hi, what's up? You're welcome to our class for tonight. In your own words, how can you define periodic table? What is periodic table? Or when you see the periodic table, what comes to mind? When you see periodic table, what comes to mind? Are you people still typing? What is the periodic table? What does the periodic table tells us about? Okay. Good evening, Moyo. Sorry, Lua. I'm fine. I hope you are doing fine too. Okay. Periodic table is the arrangement of elements according to their atomic numbers. Yes, good. Periodic table is the tabular arrangement of chemical elements. Yes, that's good. Okay, this is the table. This is the table. Yes. Periodic table is the arrangement of elements in groups and periods according to their atomic number. Yeah, you people are great. So everybody, let's just keep tapping on the screen. Let's keep liking. Good. So now, that is basically it. The periodic table is a table that shows us the elements. The periodic table is a table that shows us elements, our chemical elements, and the elements in the periodic table are arranged in order of their atomic numbers. Their atomic numbers, right? Their atomic numbers. That's one thing you people need to know. First, the periodic table, elements in the periodic table are arranged in terms or in relations to their atomic numbers, right? I hope you people are following me. I'm going to be explicit. I'm going to be explaining everything you need to know. Now, what is atomic number? They said that elements are arranged in terms of their atomic number. You want to draw, you don't have to, see now, this is, you don't have to draw now. The periodic table, you always have access to the periodic table. Just search online, you see the periodic table. Just listen to what I want to teach now. You understand? It's not the drawing that matters. Understand? It's the explanation that you need the most right now. Yes. Understand? So, what is atomic number? It is said that the atomic number of sodium, we all know sodium, right? Sodium. They say that the atomic number of sodium is 11. What are they trying to tell us? Or what information can you deduce from this thing? That the atomic number of sodium is 11. Oh, what information can you deduce from that? The atomic number of sodium is 11. What information can you deduce from that statement? And Any information you deduce from it will tell us what atomic number is. The atomic number of sodium is 11. What information can you deduce from that particular statement? It means the proton number of sodium is 11. Simple as ABC. Simple as ABC. The atomic number tells us the number of protons in the nucleus of an atom. Let us say this is an atom. In an atom, we have what we call the nucleus, right? The nucleus of an atom, right? And we have the shell. Let's say this is the shell. So in the nucleus, I'm trying to explain things about the atomic model now. In the nucleus of an atom, we have the protons and the protons plus the neutrons, right? Those are the subatomic particles that are in the nucleus, right? The protons and the neutrons. Why in the shell? This is the shell, right? In the shell, we have the electrons. These are simple things you should know. You should know that the protons are positively charged. Protons are positively charged. Neutrons have no charge, or we say they are neutrally charged. Neutrons have no charge. Neutrons have no charge, or we say they are neutrally charged, right? Electrons are negatively charged, right? Electrons are negatively charged. So the atomic number of an element tells us the number of protons that are in the nucleus of that element. Somebody was saying something before that the electron plus proton. No, that's not the atomic number. Atomic number is the number of protons alone, right? It is the mass number, that is the number of protons plus the number of neutrons. The mass number. The mass number is the number of protons plus the number of neutrons. Do you people get? So that is that for that. So now let us go back. Our periodic table, elements on the periodic table are arranged in order of their atomic numbers, right? And that is something that was proposed by Henry Moseley. The first periodic table that was first developed was developed by Dmitry Mendeleev. Don't forget this, you can be asked in your JAMB exam. The first periodic table, Dmitry, I'm coming on. Dmitry Mendeleev. Yes, the first periodic table was first done by this man, Dmitry Mendeleev. Afterwards, the periodic table was now advanced on. You understand? If you have been following me, type yes. If you have been following me, type yes. I want to know the people that are following me. If you have been following me, type yes. If you have been following me, type yes. Good. Okay. How do you guys see our YouTube class? How do you guys see it? How do you guys see it? Do you guys see that it is flowing well? And other people can also see the class afterwards. Okay. This is Dmitry Mendeleev. This is the name, Dmitry Mendeleev. You guys can see that our YouTube class is flowing well. It is not like TikTok that they usually misbehave. Okay, so now, that was the first person that did the periodic table. You people should note that. This is the name, Dmitry Mendeleev. Dmitry Mendeleev. This is the name for the person that was saying that you cannot see it. Let's keep tapping, let's keep liking. Dmitry Mendeleev. So let us continue our class, right? So now, we have spoken about Dimitri Mendeleev, was the first person. Afterwards, Henry Moseley actually developed the periodic table and made the periodic table to be arranged in order of atomic numbers. Because at first, the periodic table was first arranged in metals, non-metals, and metalloids. Afterwards, it was arranged in according to mass number. But now, at present, the periodic table is arranged in order of atomic numbers. I believe everybody has gotten that. Now, there is something. Are you not taking class on TikTok today? We have already done our class on TikTok. Oh. I already said I will be moving all our classes to YouTube now because TikTok is really giving me a hard time. They are not allowing people that actually didn't attend the class to have access to the class again. And that is something YouTube is giving me access to. So I have to use YouTube. And YouTube notifies my students early when they turn on the notification bell. So you should go and turn on your notification bell. Turn on your notification bell. If I come live right now by 10, YouTube will notify you by 10. And that is what we want. I don't want a situation whereby you will be missing classes and you will be coming late. I don't like it. So now, let us continue. And I even like this YouTube. It's flowing well. Elements on the periodic table, they are arranged in order of atomic numbers. This YouTube now is flowing well. No distraction, nothing. It's not like TikTok. Even myself, I prefer YouTube. No distraction. So elements are arranged in order of their atomic numbers. Now, there is something on the periodic table. You might know this before, but I want to make you understand it better. We call the groups and the periods. The groups and the periods, right? The groups and periods. You see, you can see. Moyo, sorry. Thank God I turned on notification. You see, YouTube informed that immediately. That is something that TikTok does not do. And this is why we need to move to YouTube. Groups and periods. Now, what are groups? Groups are the vertical. Groups are the vertical. You people know the meaning of vertical. These are vertical lines. These are vertical lines, right? These are vertical lines. Groups are the vertical groups are the vertical arrangement of elements. Groups are the vertical arrangement of elements on the periodic table. So on the periodic table, we have 8 groups. Where to turn on notification? Wow, that's not difficult now. Go to my main YouTube page. You will see one thing that looks like a bell. You will see one thing that looks like a bell. Just click on that bell. And just click on that bell. That means that you have turned on the notification. Right? Good evening, sir. First time. Yes, you're welcome. You're welcome. I believe you have subscribed to my YouTube channel. So groups are the vertical arrangement of elements on the periodic table. So now, on the periodic table, if they ask you in your JAMB exam, like how many groups are there in the periodic table? In the periodic table, there are 18 groups, which is 1, 2, 3, 4, 5, 6, till this place. There are 18 groups. The total number of groups on the periodic table are 18, right? We have 18 groups on the periodic table, right? But there is something that we call the main group. The main group, right? The main group. Henry Moseley, I say Henry Moseley, mostly modified the periodic table, mostly. This is his name. So, we have the main group. So, in talking about the main groups, we have 8 main groups on the periodic table, which is group 1, group 2, and then we move to this boron family, group 3, group 4, 5, 6, 7, 8. We have 8 main groups and 18 groups on the periodic table. Are you guys following me? Why periods? Periods are the horizontal. Periods are the horizontal. These are horizontal lines. These are horizontal lines, right? These are horizontal lines. Periods are the horizontal arrangement of elements on the periodic table, right? Periods are the horizontal arrangement of elements on the periodic table. That means that from hydrogen like this to helium like this, they belong to the same period, right? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, they all belong to the same period, right? Okay, thank God, thank God, thank God. I'm here for you guys. I'm just trying to teach you guys as many things before I'll start my classes, because if I start my classes, I'm going to be busy with medical school. I believe you all know that I'm a medical student, so I'm going to be busy with medical school. That is why I'm trying to utilize all the time I have now to teach you people all of these things, so that anytime I get busy, you people will still have things to lean on. That is why I'm insisting that we do this thing on YouTube, so that YouTube will save it. If YouTube saves it, you can always come back to watch it again if you forget anything. Unlike TikTok, you understand? I'm fending for you guys, and I'm also fending for myself, because I know that there's going to be a time where I'm going to be very busy, and I will not have time to come and be teaching what I've taught again. I will not have that time. You understand? That is why we need to be doing this here. You understand? So let us continue. Let us continue. Somebody said something. Yes, Dimitri Mandelev. Yeah, it's actually DM. This is correct spelling of the name. This is how the name is. Dimitri. Yeah, I added an I before. This correct spelling is Dimitri. DMI like this. Dimitri Mandelev. You understand? So let us continue what we are doing. Right? Okay, thank you, Jerry, my brother. So now, those are periods. So don't forget that we have 7 periods. We have 7 periods on the periodic table. We have 7 periods on the periodic table. Okay, easy bank. Good. We have 7 periods on the periodic table, while we have 8 main groups and 18 groups on the periodic table. Now, each group of the periodic table have their special names, right? And which is the main reason I drew all of these arrows. These arrows. Each group on the periodic table have their special names, right? And these particular elements that are here, they have a special name. And their special name is what? The elements that are here, what's their special name? What's their special name? I'm waiting for you guys before I say it. What's the special names of the elements that are in this particular section of the periodic table? This particular section. What is the name of those elements? Wow, this particular section of the periodic table, what is the name of the elements that are there? What is the name of the elements that are in this particular section of the periodic table? The transition metals. We call them the transition metals, or we call them the transition elements. The transition metals, or we call them the transition elements. The transition elements. Wow. Transition elements, right? So I believe people are following me. Right? Yeah, we have 8 main groups. 8 main groups, right? Why we have 18 groups in total. 1, 2, 3, 4, 5, 6 till 18. You understand? We have 8 main groups, while we have 18 groups in total. That's for peculiar shuku. You understand? So the transition elements, they are found here from between this group 2 and this group 13. That is where our transition elements are found, or the transition metals, right? So let us continue now. I'm still going to tell you a lot of things, This is something you should know. But yes, good. Thank God I remember this. So, do you people know about the SPDF orbitals? The SPDF orbitals. Do you people know about the SPDF orbitals? Good. Let me ask you a question first. Do you know what orbitals are? I want to ensure that the way I teach you people in this class, everybody will understand. Do you people know what orbitals are? See, orbitals. Let me explain what orbitals are. Some people know what orbitals are, why some people don't. Orbitals are locations. Orbitals are locations on the shell. Orbitals are locations. You know, I told people that electrons are always on the shells, right? So orbitals are located. You know that you should not forget that electrons are always in motion. Electrons, they usually move. They move around. So orbitals are locations on the shell where the probability of finding an electron is maximum, right? Orbitals are locations on the shells where the probability of finding an electron is maximum. See, these orbitals, they have SPDF, they have their full meaning. They can ask you in JAMB. SPDF. S means sharp. P means principal. D means diffuse. And F means fundamental. Somebody said I should come again. Somebody said I should come again. Okay, the first thing I said, I told you guys that there are orbitals. And I said that orbitals are the locations on the shells. Orbitals are locations on the shell, right? Where the probability of finding an electron is maximum. You understand? Yes, okay. You people also learn hybridization too. No wahala. Everything. Good. So orbitals are locations on the shell where the probability of finding electrons is maximum. And I said that we have SPDF orbitals, right? And I said that these SPDF, they have a meaning. They have meaning. So, and I say meaning of S is sharp, P principal, D diffuse, and F is fundamental. And these orbitals, they have their shape. This is not really necessary, but I just feel like, let me tell you people. The shape of the S orbital is spherical. The S orbital is spherical. Just know this. You don't have to stress yourself. Just know this. All of these things are like, they are microscopic stuff. You understand? It's spherical. The shape of the S orbital is spherical. The shape of the P orbital is dumbbell. Yeah, somebody is saying it's sharp. I'm so happy that I'm teaching you people. I'm so happy. The shape of the D orbital is what? Is double dumbbell. It's double dumbbell. And the shape of the F orbitals is complex, right? That one is complex. Yes. Ah, God. Adewe Israel, he said that orbitals are regions around an atom's nucleus, right? Where electrons are mostly likely to be found. That's what I think. Yes, it's the same thing. Don't forget that the nucleus are inside. The nucleus are inside, right? So the shell surrounds the nucleus, right? The shell surround the nucleus. So your definition, whatever you are trying to say, is also the same. It's just the grammar. You understand? Orbitals are regions around. You can see it's around the nucleus, around, and that's in the shell. You understand? I hope you understand. Adewe Israel. Do you understand now? where the probability of finding electrons is maximum. Are they where it's red? Do you understand what I'm saying now? So these are the shapes of these orbitals, right? So let's just leave that for now. But don't forget that I have made a video on writing electronic configurations. I have made a video on writing of electronic configurations where I taught people how to write electronic configurations of 1s2, 2s2, and so on and so forth. So now, what I'm just trying to drive at is that elements that belong to group 1 and group 2, right? Elements that belong to group 1 and group 2, like their valence electron is always on in s orbital. S. I'm coming. Let me just do something really quickly. I'm coming on. I just want to tell you something. Let's say this is the periodic table. And under the periodic table, we have the lanthanides and actinides, right? See, the group 1 and group 2, they are always in the s orbital. S, P, the group 3 to group 8, or the group 13 to group 18, they are always in the p orbital. Don't forget that the elements there, right? The metals, the transition elements, they are always in the d orbital, right? They're always in the d orbital, right? Hope you guys are following me. Always in the d orbital, or you can see that the last orbital they can have. Understand? I hope you are following me. Why? For the lanthanides and actinides, you have the f orbital, right? So this is what we call the s block. We call them in terms of block. This is what we call the s block. This is what we call the s block. This is what we call the p block. This is what we call the d block. And this is what we call the f block. You understand? So if you don't see it inside your JAMB exam, that they might not ask you directly that the elements that are between group 2 and group 13 are called what? They can just ask you that the elements that are in the D block are, okay, and I'm asking you that question now. The elements that are in the D block are, what is the name of the elements that are in the D block? So what is the name of the elements that are in the D block? I'm waiting for your answers. Good. Transition metals. So that way, JAMB will not get to confuse you. You understand? So the periodic table is divided into 4 blocks. We have the S block, P block, D block, and F block, right? The S block, group 1, group 2. P block, group 13 to group 18. That's what, in terms of the main group, you can see the group 3 to group 8, right? The D block, you have your transition metals. The F block, you have your lanthanides and actinides, right? You have the lanthanides and actinides where you have more of radioactive elements. So let us continue now that we have divided the periodic table into blocks. So now, if you have been enjoying this class so far, just type yes, or just drop love emoji, just see anything that you have been enjoying the class, because I'm trying my best. You can see that my voice is calm, safe. I'm trying to be taking it slowly with you guys. You will notice that my voice is calm, that everybody will understand. If anybody is here that does not understand, that means that the person is not following me. Okay. What about the name of the SP block? Yeah, I'm going to tell you the special names of all the groups. I'm going to tell you the special names of all the groups, right? So now let us start with the special names of all the groups, right? So let us start with our normal group 1. What is the special name of group 1? Wait. Before we talk about the special name, I want to tell you one thing about This thing is very, very important. JAMB likes asking questions on it. Periods and groups, right? See, the period that an element belongs to will tell you the number of shells, right? The period an element belongs to will tell you the number of shells that element will have. If an element belongs to period 1, it will have 1 shell. If an element belongs to period 2, it will have 2 shells. If an element belongs to period 6, it will have 6 shells. I believe you got that. So now, for groups, it will tell you the number of valence electrons, right? The group an element belongs to will tell you the number of valence electrons, right? The group an element belongs to will tell you the number of valence electrons that element we have. Yeah, of course, you can watch the video later. That's the beauty of us using YouTube. Because when we use YouTube, you can always come back to watch the session. So, the group tells us the number of valence electrons. Do you people know what valence electrons are? Is there anybody here that doesn't know what valence electrons are? Valence electrons are the electrons that are in the outermost shell. Or we call them valence electrons are the electrons that are in the valence shell. Right? So, groups tells us the number of valence electrons. That means that elements that are in the same group we have the same number of valence electrons. And elements that are in the same period we have the same number of shells. Do we get that simple logic now? Do we get that simple logic? Elements in the same group, we have the same number of valence electrons, while elements in the same period, we have the same number of shells. So, that is that for that. So, let us continue. Okay, somebody said I should give you an example. For example now, let me give you an example on group first. See, on period first, period 1 of the periodic table. What are the elements that we have on period 1? We have hydrogen and helium. Those are the 2 elements that we have on period 1. They are on period 1. What does that tell you? That tells you that what? They will have what amount of shells? Helium and hydrogen, they are on period 1. That tells you that they will have how many shells? If helium and hydrogen are on period 1, it tells us they will have how many shells? Good. It tells us that they will have 1 shell. Do you get the point? It tells us that they will have 1 shell. Let me give you guys another example. Let's go to other periods now. For example now, period 2. Elements that are in the period 2, you see lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. They are in period 2. What does that tell you about them? How many shells do you think elements in period 2 we have? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. It tells you that they will have 2 shells because they are in period 2. Do you get me? It tells you that they will have 2 shells because they are in period 2. So that is how it goes. For group, somebody was asking me to make an example. For groups, should we use group 1 elements, or we can use any group? For group 1 elements, hydrogen, lithium, sodium, potassium, and so on, even rubidium, they are group 1 elements. That tells us that they will have 1 valence electron. Hydrogen, lithium, sodium, potassium, they all have 1 valence electrons. They all have 1 valence electrons because they belong to group 1. Group 2, we have beryllium, magnesium, calcium. They all have 2 valence electrons because they belong to group 2. If you go like this, boron, aluminum, gallium, indium, thallium, all these ones, they have 3 valence electrons because they belong to group 13, or we can say group 3 in terms of the main group elements, right? if you go to the next group, which is this for carbon, which is group 4 or group 14, depending on the normal naming, carbon, silicon, germanium, tin, and lead, they all have 4 valence electrons. You understand? That kind of a stuff. So the group that elements belong to tells us the amount of valence electrons, right? So now let us talk about the special name of each groups. This live will be ending by 12 a.m. right? So group 1, what is the special name for group 1 elements? What is the special name for group 1 elements? Alkali metals. Alkali metals. That is the special name for group 1 elements. If I'm asking you a question, you should be talking on. For group 1 elements, their special name is alkali metals. Why are they called alkali metals? Because they form alkali when dissolved in water. You understand? When they react with water, they form alkalis. You understand? They form alkalis when they react with water. You understand? So one thing you should also know about group 1 elements is that group 1 elements, they are very reactive. Group 1 elements are very, very reactive. They are very, very reactive. Lithium, sodium, they are very, very reactive elements. And they are also soft. They are soft. And we usually store them under oil. We store them under oil. Why do we store them under oil? Because of their reactivity. They are very, very reactive. You understand? We store them, you can see we store them under oil or paraffin oil. You understand? They are very, very reactive. Why? Wait, why are they reactive first? Let us use sodium as an example. Let us use sodium as an example. I want to explain some simple concepts in chemistry to you people. Things that will make you understand chemistry better. See, sodium. We all know that sodium has an atomic number of 11, right? See, if you are talking about reactivity of elements, that if you want to know that an element is reactive, you know that in chemistry, one main thing that we usually look out for is stability. Stability. All elements are looking for stability because they just have exactly. My classes is usually by 10 p.m. Classes here will be starting by 10 p.m. to 12 a.m. to 12 a.m. 12 p.m. to 12 a.m. because of stability. Okay, let me come again. See, sodium. I have not even started explaining. I was just saying that elements are all looking for stability. When you say an element is reactive, it means that with what taste is it attaining stability, or with what power is it attaining stability? You understand what I'm saying? Like, how hungry is that element for stability, or how easy can that element be stable, or how easy can that element become stable? Now, first, when you talk about stability, that means element attaining octets or duplets depending. You understand? So now, sodium now, it has 11 electrons. Sodium has 11 electrons, right? It also has 11 protons, right? So it has 11 electrons. In the first shell, it will have 2 electrons, right? In the second shell, it will have 8 electrons, right? And in the third shell, it will have 1 electron. I believe you guys are following me. That makes 11 electrons, right? That makes 11 electrons. That means that it has 1 valence electron. You can see it has 1 valence electron, right? Because it belongs to group 1. It has 1 valence electron. I hope you guys are following me. It has 1 valence electron because it belongs to group 1. Now, it wants to attain stability. For sodium to attain stability, for it to attain octets, it will need to lose this 1 electron for sodium to attain octets, octets means that it wants to have 8 electrons. It wants to have 8 electrons in its outermost shell. It will have to lose this 1 electron, right? So it's just 1 electron. It is easy. It is easy for sodium to lose this 1 electron. The ionization energy is very low. The ionization is, I will still explain what ionization energy is and all of those periodic trends, because JAMB likes asking questions on periodic trends. I will explain everything in this live session, but that means we'll take time maybe we'll hear it by 12:20 or 12:30 or so. You understand? So sodium, it will only take a small ionization energy for sodium to become stable. It will just lose this 1 electron and it will become 2,8. Or that's what we call 2 is what we call the sodium ion. The sodium ion, Na plus. You understand? You understand? Because it has lost 1 electron, right? So now, sodium can easily become stable. So that is why it is very reactive. Elements that can easily become stable, they are called reactive elements. Why non-reactive elements are elements that probably they are already stable. They are not looking for anything again. For example now, the noble gases. I've never started explaining now. The noble gases now, or the group 18 elements. The group 18 elements, right? Where we have helium, we have argon, we have xenon, we have oxygen, and krypton, and krypton. We have krypton also. Krypton. All of these, they are already stable. So they are stable, which is the reason why they are unreactive. Oh, I didn't even add neon. Neon is also part. They are unreactive. Why? Because they are already stable. You can understand that kind of stuff. They are unreactive because they are already stable. So that is that about that. So group 1 elements are reactive. They are reactive because they can easily lose their outermost electron to become stable, right? So group 2 elements are called what? Group 2 elements are called what? Group 2 elements are called what? I'm waiting for you guys. You should not forget to be liking the live. Just tap and also share the live to your friends that you feel they will need this live to join up and also to learn. Don't forget to share this live with your friends. Okay, group 2 elements are called what? Group 2 elements are called the alkaline earth metals. The group 2 elements are called the alkaline earth metals. The alkaline earth metals. The alkaline earth metals, right? Okay, the alkaline earth metals, which are the group 2 elements also, they are also reactive, but they are not as reactive as the group 1 elements because they have 2 electrons in their outermost shell. They have 2 valence electrons. So they are also reactive. They can lose the 2 electrons when they bond with group 6 elements, something like all those oxygen, so for them, you understand? But they are not as reactive as the group 1 elements, right? So we move to the next group, which is our normal group 3 or group 13, right? And this we call them the boron family. We call them the boron family because boron is starting it, right? Are you guys following me? Let me know if you guys are following me. Are you guys following me? Let me know if you guys are following me. If you are following, type I am following. If you are following, type I am following. Good evening, other precious. All right, so let us continue, right? So group 3 or group 13, they are called the boron family, right? Let us, and boron family, we all know they will have 3 valence electrons for sure because they are the group 3. You can see the members. After we have the C, the group 4, that's our normal, we call that the carbon family. We call them the carbon family. We call them the carbon family, right? We call them the carbon family. We call them the carbon family. You can see their members. See, silicon, even silicon. Silicon is a metalloid. Even germanium is also a metalloid, right? They are like semiconductors. You understand? So that's for group 4. And you know, one very prominent member of the group 4 element is carbon, which is the backbone of organic compounds, right? Carbon is the backbone of organic compounds. So that's something you guys should never forget. Okay, yeah, you don't worry, you don't need to screenshot, don't worry. You'll be able to see or you'll be able to view the the recording of the live after we finish. When we finish, you'll be able to watch everything again. So don't stress yourself. That's the reason we are switching to YouTube, so you can always come back to watch them. So we'll be coming live on YouTube by 10 p.m. every day to teach concepts on chemistry for your JAMB exam. You understand? So let us continue. That's where you have the carbon family. That's the group 4 elements. So let's move to the group 5 elements, starting from nitrogen, phosphorus, arsenic, antimony, and even just like that, bismuth. So I think this is already mixed. Okay, it's not mixed up. Our group, the group 5 or the group 15 elements, starting from nitrogen, they are called, you can either call them the nitrogen family or you call them the nitrogens. You can either call them the nitrogen family or you call them the nitrogens. You understand? You either call them the nitrogen family or you call them the nitrogens. They have 5 valence electrons. Why does the response on comments comes first before the question is being asked on the live video? Or is it my network? I think it is your network actually. Just ensure you are following the live. Just ensure you are following what I'm teaching. The comments might lag a bit, but just ensure that you are following. You understand? Is your chemistry teacher on YouTube? For now on my YouTube channel, I focus more on chemistry, but I also give tips on biology, physics, mathematics, and use of English here also. But I personally teach chemistry. I also have a JAMB tutorial. I have a JAMB tutorial where we teach chemistry, physics, biology, mathematics, and use of English. If you want to join the JAMB tutorial, you can send me a message on WhatsApp. So let us continue. If you are following me, let me know. If you are following, type I am following. If you are following, type I am following so that we can continue. We spoke about nitrogens. Those are the group 5 or the group 15 elements consisting of nitrogen, phosphorus, arsenic, antimony, and bismuth. Good. So now we'll move to the next group, which is group 6 or our group 16, starting from oxygen, right? Oxygen, right? Oxygen, sulfur, selenium, tellurium, and polonium, and so on. So those ones, we call them the oxygen family. We either call them the oxygen family or we call them the chalcogens. Either call them the oxygen family or call them the chalcogens. Right? Chalcogens. Don't forget all of these names. They are quite important because you can be asked in your JAMB exam, right? So let us move. So after the chalcogens, we move to the group 7 elements. group 7 elements, starting from fluorine, chlorine, bromine, iodine, and astatine, right? These ones, we call them the halogens. They are my best elements on the periodic table. I love them a lot. I love the halogens a lot. They are my best on the periodic table. I love them a lot. The halogens are the most reactive elements on the table, on the periodic table. Everybody now, I want you to type halogens are the most reactive elements on the periodic table. Everybody type so that you don't forget. Halogens are the most reactive elements on the periodic table. Halogens are the most reactive elements on the periodic table. I want you to type that in the comments. Halogens are the most reactive elements on the periodic table. Halogens are the most reactive elements on the periodic table. Type that in the chat box. Halogens are the most reactive elements on the periodic table. Good, good, good. Halogens are the most reactive elements on the periodic table. So the way you have said that now, I don't think you should forget. Don't forget that halogens are the most reactive elements on the periodic table. And another thing you also need to know is that fluorine is the most reactive element on the periodic table. Fluorine is the first member of the halogens. Fluorine is the first member of the halogens, and it is the most reactive element on the periodic table. So now everybody type fluorine is the most reactive element on the periodic table. Fluorine is the most reactive element on the periodic table. Don't forget, fluorine is the most reactive element on the periodic table. Type that in the chat box. I'm saying you should type this thing because I want you to remember on your JAMB exam. Fluorine is the most reactive element on the periodic table. Good. Fluorine is the most reactive element on the periodic table, right? So let us move to the next. See, halogens. They can ask you this thing in your JAMB exam, that what does halogen means? The word halo. We all know that the word halo, this prefix halo, it means salt. Salt, right? So halogens means salt formers. Halogens means salt formers. They form salts. Halogens, they form salts, just like sodium chloride, which is our normal NaCl, right? Sodium chloride, NaCl, that's a salt. So the last group is the words. Our last group, the stable ones, the ones that they are stable, the most less reactive, the unreactive ones, the unreactive elements on the periodic table. They are the last group. What is their name? They can be called the noble. They can be called the inert. They can also be called the rare gases. The rare gases. Right? They can be called the noble gases. They can be called the inert gases. They can also be called the rare gases. I hope you guys are following me, right? I hope you guys are following me. So now, basically, we've spoken about different groups of the periodic table, right? What I feel now we should move to is we should talk about the transition elements. We are not going to be spending time on transition elements, but I'm going to be telling you some special characteristics of the transition elements that JAMB likes asking. JAMB likes asking questions on, yes, it is called group 0. It is called group 0. It is called group 18. It is even called group 8. If you want to consider in terms of the main group elements, the last group is called group 0, group 18, or even group 8. Yeah, J groups, that's it. So now I want to tell you guys some special characteristics of the transition metals. JAMB can ask you, JAMB likes asking that question on characteristics of transition metals. So I will try to write as maybe like 5 characteristics of transition metals. If we should keep tapping on the screen, let's keep liking. Characteristics of transition metals. Transition metals, the first thing you should know is that transition metals, they are all metals. All elements in the transition block are all metals. That's the first thing you should know about the transition elements. They are all metals. Another thing you should know about transition elements is that they can possess variable oxidation states. They can possess variable oxidation states, right? I believe you guys are following me. Transition elements can possess variable oxidation states. Chromium can have oxidation state of +5, can even have oxidation state of +7, and some others, depending on the compound it is in. Good. They have incomplete D or F subshell. Good. Yes, you people are really following me. Yes. They have incompletely D free of F subshell. Another thing also, they form complex ions. They form complex ions too. They form complexes. Or let's just say they form complexes. Or they form complexes. Or you can just say they form colored complexes. Let's say they also form colored ions. They also form colored ions. What else? Some of them are paramagnetic. Yes. Some are paramagnetic, yeah. Or you can say they are paramagnetic. They are paramagnetic in nature. You understand? Or you can generally say that they are, because almost all of them are paramagnetic in nature. Why some are ferromagnetic? That means they are highly paramagnetic. You understand? You say they are ferromagnetic, that means they are highly paramagnetic. Like iron is a ferromagnetic. Iron is a ferromagnetic element in the transition metals. Somebody was asking about the elements in the transition metals. Elements in transition metal, we have scandium, chromium, titanium, vanadium. Yes. I will not forget periodic table and periodic trends. Yeah. JAMB like asking questions on those two. So in short, you should know these special characteristics of the transition elements. You should know the special characteristics of the transition elements. Right? So know this. So now let us move to another thing that JAMB likes asking questions on, which is another thing that JAMB likes asking questions from, which is the periodic trends. The periodic trends, right? In the periodic trends, that's where you have the atomic radii. You have the ionization energy, you have electronegativity, you have your electropositivity, or you can call it the metallic character, electropositivity, or you can call it metallic character, metallic ability, or metallic character, right? Also, you have your electron affinity. What else? There are other things, even ionic radii. There are other things. You understand? So, 1, 2, 3, 4, 5. Let's just talk about these 5 trends for today. Let's talk about these 5 trends for today. If you are still here and if you are still following me, type I am following. Let me know the number of people that are here. If you know you are here, type I am following. I want to hear from everybody. So let me know the number of people that are here, because I'm seeing 13 people. 1, 2, 3. I'm counting on 4, 5, 6. Wow, is it only 6 people? 7, 8. 9. Yeah, we're up to 30 before. Maybe some people exhausted their data, or probably some people just left because they want to sleep. Let's just continue. Let's continue. Now we won't write JAMB. So now, I believe people know what an atomic radius is. The first thing, I believe people know what atomic radius is. Let me explain. Let's say this is the nucleus of an atom, and this is the first shell. This is the second shell. The atomic radius is the distance from the nucleus to the outermost shell. Just like the radius of a circle. That's how the atomic radius is. So, as the shell of an atom increases, the atomic radius also will increase. You understand? As the shell increases, or as the shell number increases, the atomic radius also increases. Right? You can see the difference from here to here to here. So as the shell increases, the atomic radius also increases. The atomic radius is the distance from the nucleus to the outermost shell. If for this particular one that I drew now, this is the outermost shell. So that is that for atomic radii, right? So now, the trend of atomic radius is that atomic radius increases down groups. As you go down the group. Wait. I think I want to find a way to do this that is going to be easy for us. Atomic radius increases down groups, right? As you go down the group, atomic radius increases, right? As you go down the group, atomic radius increases, but it decreases as you move across periods from left to right. Atomic radius decreases as you move across the periods from left to right. You understand? Okay. Somebody say it can't. Okay. I will explain why it decreases. Should I explain why? some people are disagreeing that the atomic radius will not reduce as you go across periods, right? Let me explain why for the people that wants to know why. Good, that makes sense. So now, from your basic knowledge in physics, from your basic, okay, you are responding to somebody else. Okay, yeah. At the same time, let me explain another thing. At the same time, let me explain. You know, some people are confused. Let me explain and show them why. From your basic knowledge of charges, you should know that like charges, if you have a positive charge and a positive charge, what will happen? They will what? They will repel, right? Like charges repel. But if you have opposite charges, like a positive charge and a negative charge, what will happen? They will attract, right? If you have negative charges and negative charges, those are like charges. What will happen? They will repel, right? Okay, don't forget this. Now, remember that I told you guys when I first started this class, I told you guys something, that in the nucleus of a shell, right, we have the protons. Let me say the protons, and I said the protons are what? Positively charged, right? And we also have the neutrons, and I said that the neutrons, they have no charge. The neutrons have no charge. The neutrons have no charge, right? I said that the neutrons have no charge. And now, on the shell, I said that on the shell, we have the electrons, right? I said that the shells, we have the electrons, right? And the electrons have a negative charge, right? The electrons have a negative charge, right? I hope people are getting. So now, in short, if you see, you can even see a question about this in your JAMB exam. That, let me ask you, what is the charge of the nucleus? What is the charge of the nucleus? I'm asking you a question right now. What is the charge of the nucleus? What is the charge of the nucleus? Is the nucleus positively charged or is it negatively charged? Oh, my power bank is dead, oh. My power bank is dead, and my phone is at 14%. Wow. This is not good, though. My phone is out. I think I'll have to move to the parlor. Let me move to the parlor so that I can be taking the class and also be solving. I can be taking the class and also be charging my phone at the same time. I really don't think it's going to be possible because somebody's in the parlor and I don't want to disturb the person. So I guess we just have to continue. My phone is already at 13%. So anyway, my phone dies, that's where we'll end this session. Understand? So I was asking a question before. I said that the nucleus is what? I'm asking people for the charge of the nucleus. In short, let me tell you, the nucleus is positively charged. The nucleus has a positive charge. Why? Because in the nucleus, we have the proton and the neutron. The neutron has no charge, while the proton has a positive charge. So the nucleus will take the charge of the proton. So the nucleus is positively charged. So now, are you guys following me? Are you guys following me? So now in the nucleus, this is the nucleus, positively charged nucleus, and the shell. The shell is negatively charged, right? The nucleus is positively charged and the shell is negatively charged. So according to the law of electrostatics, what will happen? The nucleus or the shell will be attracted to the nucleus, right? The shell will automatically be attracted to the nucleus because of the law of electrostatics, right? And that's what we call nuclear charge. You understand? That's what we call nuclear charge in terms of all this our trend, because nuclear charge is even a trend also. You understand? So, in short, the shells or the electrons in the shells will be attracted to the protons in the nucleus, right? So, for example, now, for group, let me give you an example now. You remember we are talking about the atomic radius, right? And I said that the atomic radius is the distance from the nucleus to the outermost shell. For elements that are, let's say, elements that belong to, some people are not agreeing with that the atomic radius reduces across periods, right? Some people are not agreeing with that let's say this is period 2 now. Let's say this is period 2 now. This is period now. Let's say this is period 2 now. Atomic radius, as we move like this, it will be reducing. It will be reducing. Though they have the same shell. Like, they can both have two shells. The elements here, we have two shells. But the distance from the nucleus to the outermost shell is not the same. This one will be farther away from the shell. This one will be closer to the shell because of the nuclear charge. Because the nucleus, because the shell is getting attracted to the nucleus. You understand? Because the shells is getting attracted to the nucleus because of a higher number of electrons. Hope you guys are following me. See now, let's say let's say this first one now, we only have one proton, one electron, right? Let's say we only have one electron in the shell, one electron in the shell, right? It will not be really attracted to the nucleus. It will not be really attracted to the nucleus compared to, let's say, another one here, let's say on group 4. The same period though, this one we have like 4 electrons. This one we have like, this one, element that is here, we have like 4 electrons in its outermost shell. It will have like 4 electrons in the outermost shell. Something like this. 1, 2, 3, 4. So all of these electrons, they'll be given a force. They'll be drawing the shell towards the nucleus because they are negatively charged and the nucleus is positively charged. You understand? That's what we call nuclear charge. You understand? Nuclear charge. The charge in the nucleus, you understand? So they'll be attracted to the nucleus. You understand that kind of stuff? So that is why as you move, the nucleus or the atomic radii will be getting smaller. It will be getting smaller. It will be getting smaller. Do you people understand? So that is that for that. So atomic radius increases as you move down groups and decreases as you go across periods from left to right. So that is that for that. Now, ionization energy. My phone is already at 10%. I just realized this phone does not die. Let me try if I can see a power bank. I don't really want this to die. I want us to finish this thing so people can come and watch it. I got a power bank. I don't know why YouTube is telling me to rotate the device backward. This was my editing now. I've already found a power bank now. I don't know why YouTube is telling me to rotate my device. Can you people see? Can you people hear me? If you can hear me, type yes, I can hear you. If you can hear me, type I can hear you. Type yes, I can hear you, so we can continue with our ionization energy. Okay. Good. So now, do you people understand atomic radius? Atomic radius increases down groups and decreases across periods. That is the trend for atomic radius. Do you people understand? Now let us move to ionization energy. Let's move to ionization energy. Let's move to ionization energy. So now, what is ionization energy? Who locked this orientation now? I did not lock any orientation. Why are they doing me like this? Okay. So now, what is ionization energy? Right? What is ionization energy? Now, ionization energy is very simple. Right? Ionization energy is the energy required to remove the most loosely bound electron from like one atom of an element, you understand that kind of stuff now. So basically, ionization energy is the energy required to remove the most loosely bound electron from the outermost shell, most times from the outermost shell, because the outermost shell's electrons are the most loosely bound electrons. You understand? So for ionization energy, ionization energy increases. Ionization energy increases across periods. Across periods. If you want me to explain why I love that, I will explain. And it decreases down groups. It is the opposite of atomic radii. Ionization energy increases across periods while it decreases down groups. Right? Okay, somebody said I should explain. So let me explain. Now, let me explain. I said that ionization energy is the energy required to remove the most loosely bound electron, right? So, let us say, let me use the picture of the periodic table that I drew. Check this periodic table very well. I said that ionization energy increases as you move across periods, right? And I said that it decreases down groups. Now, this is something you should know. See, let's use period 2 as an example. As you move from lithium to beryllium to boron to carbon to nitrogen, what will you notice? You will notice that the number of valence electrons are increasing. You know that the number of valence electrons in lithium is 1. Here is 2. Here is 3, 4, 5, 6. The number of valence electrons are increasing as you move across periods. That means that elements are tending towards stability. You understand? Elements, they are tending towards octets as you move across periods. They are getting closer to stability. So the energy that will be required to remove electrons as you go, as the elements are tending towards stability, is going to be higher. You need to put plenty force to collect things from people. Okay, let me give you an example. In a tug of war, if you are in a tug of war battle and you have 5 people by the right side, like I'm not talking about people that are different in size, like people of the same size. Let's say people that are 25 kg. Yes, 25 kg in weight. 5 25 kg people. 5 people. 5 people, 25 kg. They are pulling the strings with 15 people. These people are also 15 people are also 25 kg. Who do you think will win? Who do you think will win the tug of war? Is it the 5 people or the 15 people? Of course, it will be the 15 people. It will be hard to collect things when people are together. Just like one Yoruba adage that if we are together, like together we can make things happen better. I don't know how best to say it in all this Yoruba adage, but the thing is that as you move across periods, as you move like this, the number of electrons are actually increasing. So it's going to be difficult to remove electrons. That means that the energy that you need to put in to remove electrons is going to be higher. That is why as you move across periods, your ionization energy will increase because elements are tending towards stability, or the number of electrons are increasing as you move across periods. You understand? But while you are moving down groups, don't forget that as you are moving down groups, the first element in the first period of the first group, it only has 1 shell. The second one has 2 shells. The third one has 3 shells. Fourth one has 4 shells. You understand? Fifth one has 6 shells. You understand? Six shells, 7 shells, 8 shells, like that. So the shells are increasing. The shells are increasing. So, and as the shells are increasing, the electrons, they are getting farther away. Let me use a diagram. Let me use a diagram. See, let's say this is the first element. This is the nucleus. This is the first element in a group, right? Like let's say group 1 now, this is hydrogen, right? Let's say the next one now, this is also the nucleus. This is the first shell, and this is the second shell, right? The third element, this is the first shell, second shell, third shell. The fourth element, first shell, second shell, third shell, fourth shell, right? So as you see that as you are moving, the shells are getting bigger. And the outermost electrons, they are getting farther away from the nucleus, right? They are getting farther away from the nucleus. You people should not forget that I told you people that the nucleus is positively charged and the electrons that are on the shell are negatively charged. So they are attracted to each other, right? So as they go farther away, if you people notice that magnets, let me give you an example now. Magnets, if 2 magnets want to magnetize, if you are a person that likes playing a lot, you must have experienced this thing. If you place 2 magnets very close to each other, like opposite sides, so you put opposite side like north and south, you put them opposite each other very close, you will see that the magnetivity or the magnetic ability, it will be very high. they will quickly get magnetized. They will get attracted to each other very quickly. But as you draw them further away, as you move them further away from each other, the magnetivity or the magnetizing power will be decreasing. As you move them further away, the magnetic power will be decreasing. That is just like here. So as you are moving the positive away from the negative or the electrons, they are going to be feeling a bit loosely bounded. So if you want to remove the electrons that are in the outermost shell, you will only need little energy. You understand? You will not need plenty ionization energy to remove electrons as the shells get bigger and increase in size. Do you people understand now? So in short, ionization energy increases across periods as we move from left to right, while ionization energy decreases down groups. So do you people understand now for ionization energy? Do you people understand for ionization energy now? Should we move to the next one, or we should just go and rest? Should we move to the next one, or we should just go and rest? Should we move to the next one, or we should just go and rest? Okay, so let us move to the next thing. The next thing on our list is electronegativity. I'll be taking electronegativity and electropositivity together because they are opposite sides. They are opposites. You understand? Electropositivity and electronegativity. You understand? So, electropositivity. Yes. Electropositivity is simple. Electronegativity is also simple. See, electropositivity tells us about the tendency of an element to lose electrons. That's the positive charge. You know, I usually say this in chemistry. A positive charge means that that element has become a cation and that it has lost electrons. That's what we use positive charge for. What electronegativity, like tendency of elements to gain electrons. And in chemistry, we use negative sign for gain of electrons. So it will become an anion. An anion is a negative ion. You understand? An anion is a negative ion, right? So that's basically electropositivity and electronegativity, right? So now, you need to know that electropositive elements, most times they are metals. Metals are the ones that form cations. And you should know that metals are at the left-hand side of the periodic table, right? All those alkali metals, alkaline N metals, so they are at the right-hand side of the left-hand side of the periodic table. So the trend should not be hard for you. Electropositivity decreases. Electropositivity decreases across periods. Right? Because as you move towards the periods, you'll be getting closer to the halogens, and the halogens are known to be electronegative in nature, while the metals like the alkaline metals, alkaline earth metals, those ones are known to be electropositive in nature. So electropositivity decreases across periods and it increases down groups. right? Right? I'm going to ask you a simple question on this thing. So now, I want to ask you a question now. Okay. Which, let me ask you a question. Let's talk about halogens. We know halogens, we have fluorine, we have chlorine, we have bromine, we have iodine, we also have astatine, right? So now, I want to ask you a question. Of all of these halogens, which of them is the most electropositive? Are you people following me? Which of them is the most electropositive? Sorry, this is Sonic. Which of these is the most electropositive? I can see that some people are already saying their own. But the funniest thing is that you people missed it. Fluorine is the most electronegative. Fluorine is the most electronegative. And I said it before. I told you people to type this thing. You people typed it, and now you people are making a mistake. Astatine, on this particular level, astatine is the most electropositive. Positive. Astatine is the most electropositive on this particular thing. Fluorine is the most electronegative. You people should calm down. I saw that you could not get it that way. See this trend. I said that electropositivity decreases across periods, right? If you move like this, it will decrease, right? But it will increase down groups. As you go down the group, as you go down in a group, it will be increasing. So this is the group 7 elements. As you are going down, electropositivity will be increasing. As you go down, electropositivity will be increasing, which means that the one at the extreme or the lowest one in the group will always be the most electropositive. Do you people understand now? Do you people understand what I just explained? If you people understand, let me know so that we can move to electronegativity. Electronegativity is just the opposite of electropositivity. Oh, you weren't taught astatine in secondary school, I see. It's JAMB that you want to write. Okay, so let us move to the next one. Okay, somebody said I should re-explain. This thing is not hard. I said that electropositivity is the tendency of an element to lose electrons, right? Tendency of an element to lose electrons, right? That's electropositivity. Or tendency of an element to donate electrons. That's electropositivity. So metals are known to be electropositive in nature. They are known to be the ones that are electropositive because they usually donate. Like for example now, sodium, it has one valence electron. One electron in its outermost shell. So it can easily donate that one electron and become sodium plus. So this plus means that it is electropositive in nature. It is a cation. That means it is a positive ion. That means it is an electropositive ion. Do you understand? So metals are known to be electropositive because they have good donate. They have a character to donate. You understand? Right? So, okay, let me show you the periodic table. I think that will be better. See, can you see that on the periodic table? This is where the metals are. These are the metals, right? The metals. These are the metals. These are the metals. But here, these are non-metals. Here, if you see like this, you see that these are non-metals, right? So, if these metals are known to be the ones that are electropositive, that means that as you move across periods, electropositivity will decrease because the most electropositive elements are here. Because the most electropositive elements are here, as you move this way, electropositivity must decrease because electropositive elements are here. But if it is that you want to go from right to left, electropositivity will increase. But because the normal trend is always from left to right, so as you move the period from left to right, electropositivity will decrease because the electropositive elements are here, your left side, and they are your metals, you understand? So as you now go down, your electropositivity will increase. As you go down, your electropositivity will increase. Do you understand? Group 3 elements, boron now. Boron is a semiconductor, that is a semi-metal, or we can call it a metalloid. You understand? So it just decreases, electropositivity decreases as you move. That tells you that lithium is more electropositive than beryllium. Beryllium is more electropositive than boron. Boron is more electropositive than carbon. Carbon is more electropositive than nitrogen. Nitrogen is more electropositive than oxygen. Oxygen is more electropositive than fluorine. Do you people get the gist now? So now, for electronegativity, electronegativity is the tendency of an element to accept electrons, right? To accept electrons and become negatively charged. That's electronegativity. So when they accept electrons, they become negatively charged. That way you have something like F minus. You see, F minus, that means that fluorine has actually accepted one electron, right? You understand? So fluorine is the most electronegative element. I have said this and I've said it and said it over again. Fluorine is the most electronegative element. So non-metals at the right side of the periodic table are known to be electronegative elements, right? They take the negative sign on their ions. So they are anions. You understand now? So the trend is that electronegativity increases. It increases across periods. That's from left to right. It increases across periods while it decreases down groups. That's electronegativity. So as you move down the group, just like this. Okay, now, so let me ask you a question now. In this group of elements, these are the halogens. Which of them is the least electronegative? From this table now, or from this group of halogens, the salt formers, which of them is the least electronegative? Because I said that electronegativity decreases down groups. As you move down groups, electronegativity will decrease. So in this group, which one is the least electronegative? That is the least electronegative in this group of elements. Astatine, correct. Astatine is the least electronegative because electronegativity decreases down groups, while electronegativity increases across periods. And fluorine is the most electronegative element. I believe you guys understand that now. So another thing that is here is electron affinity. Electron affinity is also simple. Electron affinity. Electron affinity is basically an element's drive or taste for electrons. How hungry an element is for electrons. You understand? How hungry is that element? How hungry will it attach, or how hungry will it draw electrons towards itself in a bond? That's electron affinity. How, with what power with an element draw electrons towards itself in a bond? That's electron affinity. So electron affinity is very simple. It starts the same trend with electronegativity. It increases across periods, electronegativity, and it decreases down groups. So you should not forget all of these things. Electron affinity, it increases across periods. That means as you go across periods, elements tend to have more drive to receive electrons because they are tending towards stability. As they are tending towards stability, they want electrons. They will draw electrons with more power. Electrons from other elements, they will draw them with more power towards themselves. Understand? They will draw electrons from other elements towards themselves with more power, or they will draw electrons to form a bond quickly to their own side. You understand? So electronegativity increases across periods, while electronegativity decreases. Electron affinity, Jerry. Electron affinity increases across periods, while electron affinity decreases down groups. As you move down the groups, their taste for electrons decrease because the atomic radii is increasing, because the number of shells is also increasing. As the shells are increasing, their taste for electrons will also decrease. I believe you people understand this thing. So I think that will be all for today. There are still more that I can still even talk about the periodic table. It's just that I'm a bit tired and I think we've covered a bit. There's still a diagonal relationship of elements. There are some other things, but even reactions of elements particular to each group, uses of elements in each groups, and some other things, what these elements are used for. You understand? Most transition elements are used for catalysts. Yes, they act as good catalysts. That's for transition elements. You know, all those noble gases or rare gases, we use them in lightning. Yes, we use them in lightning a lot, and welding. You understand? All these group 1 elements, they are metals. Group 1 and group 2, they are metals. They can be used in different things. They can even be used in salts. Even all those oxygen ones, they can react with other atoms. Please, I repeat, electropositivity and electronegativity. Wait, this person, are you just joining up? If you are just joining up, don't worry. If you are just joining up, don't worry. You'll be able to watch the recording. Chukuma Mako Chukunobu. You can always watch the recording. The recording will always be there. You understand? So that is one of the reasons why we are doing it on YouTube. So people can always come back to watch the recording. You understand? So that's basically, what you people need to know about the periodic table. If you also learn about the reactions, group 1 element reactions with group 7 elements, group 2 reactions with group 6 elements, and so on and so forth. All of these things are things you people should know. So if you are here and you have not subscribed to my YouTube channel, you should subscribe. Also turn on the notification bell. So you'll be notified when I come live today by 10 p.m. also to start our class. Yes, we'll be moving to another topic tomorrow. I want to focus on the topics that JAMB likely set in their exams. I want to ensure that you people know those topics well. You understand? So I think that's that for that. So that's that. I love you guys, and okay, no problem. You can call 10 of your friends, you can call 20, you can call 57, no wala. So that's that for that. I love you guys. You people should sleep tight, and you people should enjoy yourself also, because we'll be meeting again. Yes, we'll be meeting again today. Yeah, time for TikTok. No, we'll be easier now. We'll be coming directly to YouTube now. Our classes will be on YouTube now. Our classes will be on YouTube. Yeah, and it's 10 p.m. because TikTok cannot keep misbehaving with us. We are tired of TikTok. TikTok will just be, they will not be allowing people, other people that miss the class to see the class. And that thing is not really something, I don't really like it. It stresses me out. You understand? So that's it. Good night, everybody. I'll see you guys later. Bye.